we're supposed to use the intercepts to graph the equation 4x plus 3y equals 12. We know that a y-intercept is when x is 0. And I'm just going to abbreviate intercept as INT here. So putting in 0 for x, well, 4 times 0 is 0. Zero plus 3y will just be 3y. And then we'll divide both sides by 3 to get that y equals 4. Our y-intercept is 0, 4. I'm going to make a table over here of the points we're finding. When you're putting in 0, when you're finding intercepts, you can actually make the work easier because we know what something times 0 is and we know what 0 plus something is. You have to be a little bit more careful with what I'm about to show when you have some subtraction involved, but basically this idea could still be used. When I was finding the y-intercept, basically I was covering up the x term, solving 3y equals 12 to get y equals 4. So now if we put in 0 for y to find the x-intercept, then I'm solving 4x equals 12. Divide both sides by 4, we'll get that x equals 3. Now, if memory serves me correctly, Dr. Chacon had also talked about a third point as a checkpoint. If I go backwards here, from this point to this point, I've gone from 3 down to 0. So how about I go down from 0 another 3, and in this case it went from 0 to 4, up 4 in the y direction. So I'm betting that the point -3, 8 is also going to be on the graph of this line. I'm actually going to check that though. Let's put in -3 for x and see if in fact we do get that y would equal 8. In this case, this would require more of the work like what I initially showed here because we're not dealing with 0. 4 times -3 is -12. Add 12 to both sides. And with 3y equals 24, divide both sides by 3. My prediction was correct of -3, 8 being another point on the graph. Now, I want you to notice how the question was asked on Pearson, though. That I was talking about, use the intercepts to graph the equation. Okay, so click to enlarge graph. And I want to show you 2 issues that come up. Select the line tool, and I'm going to try to enlarge this a bit if I can. Okay, well, one issue is what if you plot different points? It is asked for us to use the intercepts to graph the equation. So what if I use the checkpoint -3/8? Notice in the upper right-hand corner that as I move the point, it is giving me the coordinates of the point I'm at. Okay, there's -3,8. Oops. Let me clear that out. So I'm going to plot -3,8 correctly. And let's say I then plot the x-intercept of 3, 0. Again, I'm watching those points, coordinates that it's showing in the upper right-hand corner. I've got to get it right on the 3, 0. Okay, there we go. Save and check answer. Now, I feel that the advice that it's giving here, the feedback is not particularly helpful, because I did use the information about 0 for the 2 different coordinates. This should be exactly the same line that we would get by plotting them, but Pearson is not able to recognize that. MyLab Math is not able to recognize that because it wanted us to plot the intercepts. So I'm going to click to enlarge the graph and select this and delete it. So now say I go to plot 0, 4 after selecting the line tool. 0, 4, there it is. Oh, I think I got it just a little bit off, so let me clear this out. 0, 4, click on it, and then let's say I go for the x-intercepts and say I'm not paying attention to what's on the right. 3, 0. Right now I'm at 2.5, 0. If I didn't know that that stuff was up there, well, save and check answer. Nope. It wants it exact. So let's see if I can select that point. It takes the whole object away. All right. So exactly 0, 4. Click. And exactly 3, 0. Click. Save. Check the answer. If I'd still been wrong, then I could have asked for a similar question.